Welcome back to Green Disruptors, the podcast where we explore the innovators building a cleaner, more sustainable world. I'm your host, Megan Kjar, and today I'm joined by Suresh Jambunathan, founder of ENWADEV, short for Energy and Water Development. Suresh is an engineer, problem solver, and systems thinker who believes that sustainability and profitability don't have to be at odds. In this episode, he breaks down how his team helps organizations from college campuses to industrial plants rapidly cut energy and water costs through smarter integrated design. We talk about why power is often the best place to start and how to pitch green infrastructure to stakeholders with very different priorities, and why sometimes the simplest ideas are the hardest to get permitted. Suresh also shares how his firm is now moving from concept to construction, bringing resilient, affordable, and decarbonized energy to life across the U.S. Let's dive in. Welcome back to another episode of Green Disruptors. Today I've got Suresh Jambunathan with me, and he is going to tell us a little bit about who he is and what his project is. Go ahead.
Okay. Thank you, Megan. This is Suresh Jambunathan, based in the Chicago area, and I have my own little project development consulting firm. We also finance projects called Energy and Water Development. Short form is ENWADEV, the portmanteau of Energy Water Development. What we do is we help customers sustainably cut the cost of energy and water. In concrete terms, that means any facility, whether it's a large petrochemical plant or the corner subway shop, they all need energy, which is power, thermal energy in the form of chilled water, steam, even hot air, cold air, and then water and wastewater. So every facility needs utilities. We help them rapidly reduce that cost. We do it multiple ways. They include, but not limited to, what we call demand reduction. Turn on the taps, close the windows. That's a really good way to save energy. Once you've taken care of all the low-hanging fruit, and there's dozens of them, many dozens actually, we go to supply optimization. And there's a whole slew of things that can be done over there. So, and I can go into more
Sorry, I lost you on. Oh, no. Using especially water and, all these sources of energy are huge costs for a lot of these companies like food processing or mining. You're saying there's a lot of touch points and ways they can cut costs, but is there like a number one go-to that you usually start with?
I do. I usually start at power because power is often the most expensive form of energy. And that's because in most places you burn fuel to generate power. Therefore, it stands to reason power is going to cost more than the fuel used to burn it. Plus, you got to account for the return on the investment to convert fuel into power at a typical power plant, coal power plant, nuclear power plant. Nuclear plant, you don't burn fuel, but similar for this conversation, gas power plant. So always start with power, or usually start with power. And then when you generate power on site, especially by combusting fuel in what's called an on-site power plant, combined heat and power, you get the waste heat, which if you don't capture and reuse is wasted, the fuel's paid for. So for a little incremental capital investment, you can recapture the waste heat and recycle it back as steam, hot water, even chilled water. It's something known as an absorption chiller. And there's many, many ways to do it. That's on the technical side. Commercially, you have to structure the deal, and I'm happy to go into those details if there's interest.
Yeah, I have another couple of follow-up questions, but so are these companies coming to you because they're concerned about their environmental impact, or they're looking for cost savings, or is it a mixture of both?
It's a mixture of both. Until recently, they would say a lot about how green conscious they were, which is fine, and many of them actually mean it. But it's always green, meaning Benjamin Franklin, the bottom line that drives these things.
That's the real green energy.
But green is all good, but the point of business is to make money for shareholders.
And you don't have a business if you're not profitable. Yeah,
that's exactly right. So fundamentally, there is no conflict between your conscience and your wallet. By designing, installing efficient energy recycling systems, not only are you saving money at the operating level, the plant level, you're also reducing pollution, because the alternative is for the same delivered energy. It's a lot more polluting to get power from the grid or burning fuel separately in a boiler or and so on and so forth. So when you look at the alternate versus the on-site energy generation recycling, the on-site process is almost always lower polluting and less cost. In other words, you can be good and you can be green.
I mean, yeah, and that's what it needs to be because if it's too costly to implement green things, it's a business decision at the end of the day.
That's right. That's right. That's right.
Yeah.
The level of nuance there is it's always balancing the load with the supply. The load is things like the site electrical load, but there's two components to it, the peak demand and the annual
Hmm.
consumption or daily consumption. So you got to meet that load.
Yes.
But coincidentally, along with electricity, the site may need thermal energy, steam, hot water. It may need chilled water. It may need water and wastewater. So the very first step is profiling the site load profile by two submetrics, the peak demand and the consumption, and then coming up with a set of solutions to meet that load. Keeping into account that if you're watering potato field, you don't have to be very resilient. If you're powering a data center, you need extremely high resiliency. And so do you have multiple systems in parallel, which increase resiliency, but also means more cost, takes more space, and the capacity factor of each subsystem might be lower than optimal? Or, if it's a potato field, you just put one unit and run it flat pedal to metal and do it that way. So there's a little bit of trade-off there, but those are the nuances that go into system design and ultimately the profitability, the emissions profile, the security of that investment. And those are things that come into project development.
So is there a specific type of industry that you have had like great success with that you typically go after, or is it a pretty wide range?
It's a pretty wide range. So over the years, before I put up my own shingle, I worked for other companies. So corporate America, I worked for Veolia. Before that, I worked for as a project developer at a privately owned, a private equity-backed project development company. It's called Recycled Energy Development, and I learned a
Okay.
lot of things at RED. My hiring manager and mentor was a gentleman called Sean Caston. He is now the Illinois 6th District Congressman, and
Nice.
Sean and his dad, Tom Caston, were one of the finest people I've ever known. Absolutely, regardless of whether you're Democrat or Republican or whatever, but the Castons are, in my mind, two of the finest people I've had the fortune of meeting, working for. So just want to make sure that message got out. But no, the customers can be anybody. It really depends on. As a business, do you want the site to be long-term operational? And if it is, then almost certainly we can find ways to reduce your cost of energy and water sustainably.
Yeah. I imagine a lot of these, like I think about any kind of plant or something that's producing something, they've been doing things a specific way for probably a long time. Are
Mhm.
they pretty easy to persuade, or is there like a long education process before they're ready to make a decision like that?
That's a great question. So, people who are better salesmen than me, I think, do better. With me, it'll sometimes I find it harder to persuade because I realized over the years when you quote unquote persuade somebody, there's different audiences. If you're the CEO, you're thinking about strategically what message am I giving to the board, to my investors, to the universe about how I'm saving the earth. If you're CFO, you're less concerned with saving the earth, more concerned with keeping the place running, the
Yeah.
business running.
Yeah.
What's the risk of my increasing operational cash flow? If something goes wrong, or not if, but when something goes wrong, how am I protected? So there's actual operational financial question the CFO cares about. If the chief operating officer, the plant manager, you leave the grand strategic thinking to others. Day in and day out, your bonus and your job depends on keeping the place running. If the new sets of
And
pots
if
and
your
pans,
systems add extra steps or make it more difficult, they'll be like, no
tell me, wait a
thanks.
second, all this looks good on
Yeah.
PowerPoint, Excel, but it's a headache I don't need. I already got 10. I don't need 11th one. If you're the
Yeah.
regulator, especially if you're selling power to the grid, or even if you offset a lot of power, the local grid regulator wants to make sure you don't disrupt the local grid.
Mm.
Then, as far as pollution is concerned, even though CHP systems, and CHP is just one tool amongst many, reduces pollution, in other words, it's a pollution control measure, they want proof that you're actually doing so. So there are multiple things. And then the community, right? Anytime you combust something or if you're putting a new investment, the local community, the mayor, for instance, he or she wants to make sure that, ideally likes to make sure that any employment jobs go to locals because the mayor would like to, part of the mayor's job, city council job is economic development, rightfully so. So you got to address that in concern too. So there are multiple constituencies whose concerns have to be addressed. And the CFO, for instance, they know all about income statements and cash flow analysis, don't know a boiler from a chiller. ran into one. The plant
So you have
manager.
to show off different aspects of the
That's
offer
right.
depending on who you're talking to
That's
and
right. That's right.
know what their bottleneck and pain point is.
That's right.
So, what, I mean, can you maybe give me an example of like a specific company? I mean, I know there's privacy stuff, but can you give me some details about what that process looked like for a specific business?
Sure. So I won't take a name, but I'll paint an example of an industrial customer I worked with not so long ago. We put a very large project for them. Actually, not industrial customer, it's an educational institution in this case. So the project is up and running. So this educational institution in the upper Midwest, a private institute, a technology institute, they're not Harvard, but they're pretty close to them in terms of the quality of the students. Their
Okay.
energy needs are steam for most of the year, chilled water in summer, and power from the grid all the time. And the system works, but getting increasingly expensive. Plus, the current system, the energy center, the boilers are getting falling apart, the chillers are showing their age. So it's the proverbial duct tape and gum to keep the place running, right?
Yeah.
So they're looking at, the thing. So, they put an RFP for a better solution. A Chicago area firm won the RFP, and I helped them win that RFP by coming up with the solution, which is a tri-generation system. And it's under what is called a 40-year PC, public-private partnership. It's a $40 million project. It's under construction right now as we speak. It'll be up and running around this time next year. People are welcome to visit. So as part of the development process at the university, decision-making takes a long time, because number one, university's focus is education. They're not necessarily familiar with the structure of a PC public-private partnership.
Right.
And all the changes proposed, people are, concerned with risk. The back and forth, multiple questions took a long time. In parallel, as the design.
How long? I mean, is this like a years long process?
4
Okay,
years.
yeah. So very long.
Very long. My rule
It's
of
the
thumb
longest
is,
sales cycle ever.
my rule of thumb is it usually takes twice as long and costs twice as much as when you start. And if in the back of the napkin, the economics can support twice the capital investment and twice the sales cycle, you have a project. Empirically, like I won't say Moore's law, but just the homegrown law, it seems that never seems to deviate from that law. So it took 20. But it's a good project. We were helped by the fact we had the Inflation Reduction Act, which took basically a third of the capital cost off. That helped. Plus, we were able to get a very significant grant from the local utility that paid for the project. So, the utility
So you're helping these people find the capital they need to fund the project.
That's right.
That's great. That seems like does everybody do that, or is that unique to your company?
Well, most project development companies are supposed to do that. Some do it better than others, and others maybe not so much. It also depends on the counterparty. If you're a university, it's not things you do every day. If you're a large industrial conglomerate, you got half a dozen people whose job is energy. So it also depends on skill set.
That makes sense.
So in this case, we were able to do all of that, but still took a lot of time. The permitting took a lot of time. Even though we're reducing pollution, we still had to check the boxes and go through the entire effort. It's a very painful effort, in my opinion, extremely frustrating, because we were essentially asked to prove that if you replace the 10 mile per gallon car with a 20 mile per gallon car, prove to me that the newer, more efficient car pollutes less. I mean, how do you prove the obvious? Right, but we still had to go through, the process and the effort, and it's one of those things that in America we've lost the ability to do big projects using common sense. And in that sense, I'm kind of supportive of the effort to reduce the unnecessary paperwork, improving the obvious.
Yeah, well, we love paperwork, I guess. I don't know why. I hate it.
No, it's unnecessary. Paperwork is important because it's important to hold people accountable to reduce pollution. But unnecessary, mindless CYB paperwork, is defeating the ability of America as a country to.
Well, it's slow. It's just slowing it down,
Yeah,
and it's a time-sensitive problem. So
because time is money.
Yeah.
The project cost went up by almost $4 million because we lost a year in mindless paper shuffling.
Ugh, yeah. So how do you as a company deal with such long sales cycles, and like how are you finding new people to work with?
So in our company, we have a mix of what I call the singles, where project consulting provides space for the coffee, pays for breakfast, and pays for the
So it's more of not low ticket, but just easier barriers of
Easier
entry.
that.
Yeah.
Big projects take long, but when they do, they get you to the next level and different skill sets, and that's kind of nice. But they
Well,
keep the lights on with the people we have. It's just a standard, plain bread and butter, what I call conceptual design. We have a unique skill set in that we rapidly conceptualize a solution based on what we know, and we can do it typically within a day. And I'm
So you could get somebody a conceptual design plan, and then it's their job to hire out the contractors to implement the design. Is that right?
The first part is correct. The second part is not necessarily their job, because to hire the contractor, you have to go through from initial rapid back of the napkin electronic concept to a conceptual design, and then basic engineering, detail engineering, and so on. That process is not difficult, but it does require certain skill sets. Typically, a customer will ask my company to help them go through that. But I found over the years, if it makes sense in the first 1 hour, it'll make sense a year and $100,000, $1 million of engineering later. If it makes sense, the economics makes sense on a sheet of paper, literally a single sheet of paper, they will also make sense on a very complex 50 gigabyte or 50 megabyte spreadsheet. The only difference is precision. On a spreadsheet, you can be very precise, but accuracy is the same on paper or a very fancy spreadsheet. Accuracy is not the same as precision. People often conflate one for the other, but they're not. It's really important to be accurate. And precision is nice, but precision is lipstick. Accuracy is what really matters.
Well, yeah, especially, I mean, this is such a number sensitive field that you're in. Like we're trying to measure every little particle of CO2 and every megawatt of energy. Like there's not really room for guesswork, I imagine.
I mean, you can guess, but thing is, in any project, there's about 3, 4, 5, maybe 6 variables that pretty much define project feasibility from a technical, economic perspective. You can throw another 500, variables just because you can. An illustrated example is someone modeling the IRR, internal rate of return, on a 20-year window by changing the cost of toilet paper in the O&M budget, 6 years from now. Okay, fine.
And we don't know exactly what that number is going to be because we can't predict the future. Yeah. That's right. Yeah. So that's tough. So what are you most excited about right now that ENWADEV's working on?
Well, I think the energy transition we're going through right now, where we change from the old paradigm of remote distributed coal power plants, nuclear power plants, to more of a distributed generation model, the incorporation of renewable energy technologies, wind and sun, and the rapidly falling cost of those renewables, the rise of energy storage technologies, both chemical, batteries, thermal, hot water, chilled water, high temperature storage. That is, really proves the proposition. There is no conflict between your wallet and your conscience. And it's also increasing resiliency of energy supply. And energy is foundational to the quality of life. 100, 200 years ago, when people were burning wood and coal, people lived really miserable lives because, without electricity at night, you can't read. If there's a disease or something, how do you, if you don't have hot water, disease spreads. But when you have substantial energy, the quality of life, this call we are on is because there's a data center that's being powered by reliable energy. So energy supply, resilient, affordable,
like quality of life, ability to grow economically, ability for education, like all of it.
Yeah, a good quality of life. I mean, the point of all of this is that, people lives well, lives contentedly, is happy, right? At the end of the day, GDP is a number, it's an important number. But like somebody said, I'd rather be rich and unhappy than poor and unhappy.
That makes a whole lot of sense to me. Yeah. So, yeah. Okay. So let's see. Where are you at as far as growing ENWADEV, and what does the next phase of growth look like for the company, do you think?
So we are actually moving from design and consulting to actually engineering and construction. So literally, as we speak right now, besides that project at the university campus, which is under construction, that project was designed, co-developed by ENWADEV, but somebody else is constructing it and somebody is financing it. But we are literally, as we speak, in downtown Chicago, we are building a small CHP, combined heat and power, at a hotel in downtown Chicago. That project will be up and running in June. We finished engineering. This week, we are starting construction. major equipment is coming on site. We are also engineering a project in the Pacific Northwest, which I'm hopeful we'll get the construction contract too, and that one will be up and running. We have the engineering contract, but the construction will begin 3 months from now. If we get that, then we'll build that too. That'll be up and running maybe around this time next year, maybe 15 months from now. We're also looking at a couple of other projects at a horticulture facility, I'll use the broad term, where we are hoping to invest our own capital, design and build it, operate, maintain for a very long period of time, 20 years or so. And that one would be a unique project where we take the energy in the CO2 molecule, a methane molecule, pardon me, make power, use the waste heat to make chilling hot water, and finally the CO2, which is a product of methane combustion, methane is natural gas, goes into the horticulture facility, the greenhouse, to help the crops grow better. So literally the circular economy in action, and going from exergy to entropy, which is a very thermodynamic term that some of your readers or listeners might understand better.
Just because we got time, give me a brief, educate me on those two terms real quick.
Yeah. Exergy is an entropy refer to the quality of the energy. As an example, if you have, and I'm just going to use a very broad term to oversimplify, let's say you have a certain amount of energy, 100 BTUs. A BTU, British thermal unit, is like a calorie, like kilowatt hour, unit of energy, like a gallon, a liter, an ounce, right? Let's just say you have 100 BTUs of energy. That 100 BTUs of energy can be at high temperature or at low temperature, hot water versus warm water, right? Hot water is a lot more valuable, useful than warm water, because with hot water you can cook something, you can take a nice warm bath, so on and so forth. Warm water, you can't cook anything. You can put the rice or the beans in it and it'll just say lukewarm. Nothing's going to happen to it, no matter it's the same 100 BTU of energy. Exergy refers to the hot water. Entropy refers to the warm water becoming cooler, the same temperature surrounding it.
Okay. That was a good, use cooking and I'll understand every time.
But the concept of exergy is really, the $3 thermodynamics. When you say the Big Bang and the universe expanding, if you sort of think about it, ultimately they say universe is going to become a giant cold ball, like many billions of years in the future. It's because the entropy is increasing. Entropy is a measure of the disorderliness of the universe. Work is required to clean the room, right? But the room starts getting dirty again. It takes a lot more work to clean the room than to make it messy. So entropy is the messy part.
I have 3 kids. I'm very familiar with that.
Yes, I have children too. So
I try not to be too bugged, but anyway.
So hopefully that makes sense. But those terms have a very specific thermodynamic meaning. And in our real world, it has a very specific economic implication.
Do you want to go into a little more about that?
Sure. So take the example of a petrochemical plant, just because. Take the example of a greenhouse. Okay, so greenhouses are getting more and more common, or a data center. So if you take the example of a greenhouse requires power for the lights and fans and so on and so forth. They need power to run a electric centrifugal chiller to keep the place cool in summer, for the office and so on, right? And they may need hot water for space heating, for washing, and so on and so forth. Plus, they need carbon dioxide to help the plants grow better. Right? If you have CO2 in the greenhouse, the plants grow better. Or a data center, you need power to keep the computers running, and then you need chilling to keep the computers cool because the computers generate heat.
Because they heat,
So in the framework of exergy, if you want to generate power at site, you burn natural gas in the generator, right? And you make power coming out.
Mm-hmm.
Part of the energy in natural gas becomes power. The rest of it becomes waste heat. Waste heat as an exhaust or hot water from the generator. If you take the waste heat and then recycle it into a heat exchanger to make chilled water, that chilled water can be used to cool the data center. At the greenhouse, you can use chilled water to cool the place or hot water to warm the place. At the data center, you have taken the energy in the fuel, made it into higher quality of energy, which is power, take the waste heat, recycle back into chilled water, therefore saving the electricity for the electric centrifugal chiller. You save power from the grid. You save the capital cost of this chiller. So a lot of economic benefits. In the case of the greenhouse, the same natural gas makes power. The waste heat can make hot water or chilled water or both. And the exhaust, which is now cooled hot air, can go into the greenhouse to feed the plants. So that's an example of going from exergy to entropy while also
Yes.
going down, while maximizing the economic value of what you're paying for, which is the gas molecule.
Do you think we'll ever get to a point where all of these inputs and outputs can be utilized across different companies? Like maybe it's just a data center, but somebody else can buy their excess, heat from them. Like,
Yeah,
does it
absolutely.
all?
Absolutely. Great question. Absolutely. And so that comes down to integrated energy recycling. So in the example of a data center, let's say the data center is located in an abandoned building in downtown Chicago.
Sure.
Let's take Chicago,
Yeah.
my city, for instance.
Yeah.
Chicago has pretty cold winters, and through the year in any downtown building, they need hot water for building domestic hot water use, as an example. A data center thermodynamically is the same as the electric toaster oven, the same one in which you bake a bread, right?
Yeah.
Power goes in and the heat from the toaster oven warms the bread. Data center, the computers run and the waste heat is dissipated and removed from the data center room in the form of hot water or sometimes chilled water in a loop. We can take that waste heat and use that in something known as a heat pump. Feed a heat pump. Heat pump is like a refrigerator, and convert that 100-degree hot water or 100-degree warm water, 100-degree hot air, and oversimplifying, make it 200-degree hot water, which can be used for space heating, for washing the dishes in the restaurant or whatever it is. So you're recycling the waste heat. So the power comes in. Power can come from the grid or an on-site CHP system, combined heat and power system. The waste heat from the computers can be captured, recycled, the quality upgraded, meaning the temperature can be increased, and reused for the facility. Net, take a step back. By doing so, the way I'm sort of verbally describing, that particular building, a set of buildings, surrounding buildings, no longer need to burn fuel in their boilers, and because you're reusing the otherwise wasted heat. So there's economic value with the avoided fuel. There's a pollution control level. You don't have the NOx and other emissions, and it's just a good way to reuse the otherwise wasted resource. So it's absolutely possible. So one man's waste is another man's resource, so to speak.
Yeah.
But technically, it's very possible.
I'm gonna get philosophical here, but it's just funny, like how we get so us versus them culturally sometimes, but really, like, this whole model just proves how connected we are and how that can be such a powerful tool if we work together. So it's pretty exciting.
Exactly right. And so I'll give you a real example that many listeners might appreciate. So in the US, for instance, there's this perception, California, ultra left, ultra green, Texas, ultra right, and so on, right? Well, perception is one thing, and that's a fluff. The reality is, most people don't know this, but Texas has actually more wind and sun, renewable, than California does. Because as a state, Texas, and I'm from Illinois, so for me, both are, nice.
Right, I'm from neither, so.
But Texans have a very pragmatic attitude towards business.
Yeah.
And
so if it makes sense, they'll do it.
They'll do it, yeah. And it's not like, they'll tolerate pollution. The rules are very strict in what you can pollute, but it's not prescriptive. It's, outcome oriented. You shall not pollute beyond certain level, and that level is less than the alternative. How you do it, let the designer come up with a solution. So a solution, that's in my mind, that makes a lot of sense. Always state what the objective is, but don't say exactly how you should get there. Let the person figure out a way there.
Yeah. Well, and I imagine ENWADEV is probably getting pretty good at that, of helping people just see the practical next steps, the cost savings, the implementation. Like you'll make that process easier for them.
We like to think we are good at that. We like to think we are good at rapid conceptual development. We base it on first principles of thermodynamics, hydrodynamics, but circumscribed by site-specific opportunities and constraints. So what might work in the middle of a cornfield in Iowa will be different from what works in Manhattan, where there's no space.
Totally.
What works in Arizona is different from what works in Alaska. Different geographies, different cost structures, different environmental considerations to worry about, so on and so forth.
Yeah. Well, it's exciting. It just sounds like there's so much opportunity and people willing to make good business decisions. So thank you for all of your work in helping people make these transitions, and congrats on the success so far of the business.
Thank you. No, this is a very, very exciting thing for me. This is not work exactly. I actually enjoy doing it.
Yeah.
So,
I
so
feel that way. I'm spoiled just being on the podcast. And I get to talk to these super smart, interesting people who are making a huge impact, and I'm learning and having fun and whatever. So anyway, was there anything else that you wanted to talk about before we end today?
I think, I mean, from philosophy point of view, I think a person should try to find what they like to do. And it's easier said than done because, when we're kids, we're going to college, it's, the world is an oyster and there's so many choices, it's kind of hard to know.
Too many choices.
Too many choices, so it's hard to know. But I think if you kind of, find out what you like to do, then you do it, you get better at it. Or let me put it the other way around. It's a skill set that someone kind of feel they're good at and they get better and better at it. The better you get at it, the more you like it. I think in America, most people have the other way around, that I'm born good at something. I'd like to say a lot of it is, there may be some element of truth to that, but mostly is you focus on something, become good at it, and when you're good at something, you like it more and more. For me personally,
competency is rewarding.
Competency is rewarding.
Yes.
Thank you. That's very well said. Yeah, very well. So in my case, my company's case, we like to think we're very competent at what we call the conceptual design, but that really means the cartoon, schematic. But overlaid on top of that, it's a process heat and mass balance. And when the balance closes, it's a very wonderful feeling. It's like, at least for my company, for me personally, for sure, I find it a work of art, a work of beauty. I feel very happy. It's the same feeling someone might see when they go to see the Louvre, the Mona Lisa, or some beautiful painting. They ooh and ah. That's fine. Mona Lisa is great. I might pay $100 for it at the garage sale. Someone will pay $100 million for it. But it's a matter of.
But I mean, what you guys are doing is extremely powerful. Like, you could be saving companies over the long term millions of dollars, and lowering their climate impact and just making their business more efficient. Like, that's a huge impact.
It actually is, and our marketing term is RAD, resilient, affordable, decarbonized energy. The resiliency part comes from on-site recycling of resources, energy and water. The affordability part comes from it's always cheaper to do it at site and do it efficiently. And the decarbonized part is the happy consequence of efficiency.
Yes. I think that's a powerful note to end on. That's awesome. Thank you so much.
Thank you.
Okay, well, good luck in this coming year with these projects. We'll stay in touch, and excited for listeners to kind of continue to follow what you and ENWADEV are doing. Thanks again for tuning in to Green Disruptors, and thank you, Suresh, for this conversation. If this conversation got your wheels turning, share it with a colleague or a friend who's interested in energy, infrastructure, or sustainability done smarter. You can learn more about ENWADEV and their work at www.enwadev.com. If you haven't already, hit follow so you don't miss future episodes. And until next time, keep disrupting.